Am I able to see your screen when you're doing this? When you're recording this?
Yes, yes. You can see
Okay.
my screen.
No, I can see it. I'm just saying when it's recorded, I'll be able to see your
Okay,
screen.
now it's recorded. Hold on. Okay, do you see my share screen?
I see your screen. Yeah.
Okay, I make like this, yeah, Rivka. Yeah. So I give you short question. What is probability of A?
0.7.
Okay, good. Now you understand.
Okay.
Okay, what is probability of A prime?
0.3.
Okay, good. So what is probability of B given A?
Would be given A. So that would be probability of B, which is 0.4
Yes.
given A.
Yeah, so just this,
Giving
yeah.
that already 0.7.
Yes. So the answer is only 0.4, yeah. Okay?
Okay. Okay, so stop right there.
Yeah.
When I'm doing numbers and I don't have a diagram,
Yes. Yeah.
how else would I be able to get that?
Oh, okay. I will show you. I will show you later. Because this is the basic. We need to understand how we get probability of B given A, probability of A and B using tree diagram. How about this, Rika?
So yeah, so when it's visible, I can get it. It's 0.2.
Okay, good. I think you understand now.
Yeah, but
Now,
I don't understand when it's numbers only.
okay. How we
Okay.
get this? How we get this probability of A and B from this tree diagram?
A and B. So the probability of A is 0.7 and means times B. So times 0.7 times, yeah, 0.4.
Okay, so it will be. We know probability of A and B means probability of even A and even B happen first. Yeah. Sorry. Probability of even A and even B happen. Sorry, there is no word first.
At the same time.
Yes. So it will be
Okay.
0.7 times
Yeah,
0.4, 0.28. Yeah.
that's correct. Yeah.
Okay, next. How about this? Probability of A prime and B. So
0.2 times 0.3.
0.3 times 0.2, yeah. So 0.06, yeah.
Okay.
So if we add up this, yeah, we get probability of even B. Yeah. So
Okay, stop right
probability
there.
probability of
Let's see. If I have a probability of A and B, so that's the event, and then probability of A prime and B, so those two, that gives me the probability of event B happening. So that gives no, so no, okay, so this is why I'm confused. Why only event B? It's B given A and or A prime.
okay. Just memorize this. Just memorize this. Probability even B you get from probability of A and B plus probability of A prime and B. Because even B happen with even A and even B can happen with even A prime. So you just add up both. Yeah.
Okay.
So just memorize that. Just memorize that. Okay.
Okay, hold on. I need to write that down. Okay, hold on. Can you write it for me? So then when I take screen, like when I relook at it and I write
Oh, okay.
notes, I'm gonna be there. So
Okay.
basically next to event B, what you're doing is that probability of B, oh, the probability of B happening is the probability of A and B plus the probability of A prime plus B.
Yes.
It's not intuitive, eh?
Okay.
Okay.
So
Okay.
Okay,
right? Fine.
so this is example of dependent event, Rivka.
That's because one's dependent on the other.
Because you can see from here that the probability
You
of
can't have B without A or A prime.
because yeah, this is different. Yeah. Probability of B given A is different with probability of B given A prime. So that this is dependent event. Yeah. It means the occurrence
Wait,
of
just slow down. Just repeat it. I'm just trying to catch it while I'm looking at it. Just say it again. I just didn't hear. You
so
said the probability of B
the probability
given
of
A.
B
Is that what
given
you just said?
A, yeah, probability
So
of
the probability of B happening. So, and when you say B, it's not B prime as well. You're
yes,
not including B prime.
yeah. We don't discuss B
So
prime.
the
Yeah.
probability of, okay, so just the probability of just B happening, which is those two, given that what? That
Prob-
A
pro-
happened?
Probability of B given A happen first is different
Okay,
with
so it's
uh
0.4 plus 0.2 times
no 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 no
0.6,
no 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 okay
0.7?
okay okay hold on okay
Oh,
hold on, look at this. This is probability of B given A, okay, and this is probability
look,
of
I'm
B.
not seeing you move. I don't see where you're showing me. Hold on.
Okay, do you see this?
Where are you?
Hello.
I don't see your now I see your cursor. Go ahead. What did you
Okay,
say? I couldn't see it.
okay,
Yeah,
do you know this? This is probability of B given A, okay,
that's correct.
and this
Yes,
probability of B given A prime, okay,
that's correct. Yes.
so both are
So if I
different.
wanted probability of B given A, it would be 0.4
Yes.
given A. So given A, what am I doing with the given A? Something with 0.7, but I'm not sure what.
No, no, no. We don't discuss this. We don't discuss point 0.7. We don't discuss 0.3. We just discuss this. Here. Okay, look at this. This is probability of B given
Oh my
A.
God.
Okay, and this is probability of B given A prime. Okay. Okay. Do
Correct.
you agree?
But how would you write it in numbers? Yes. Yes.
Okay. Both are different. Both are different. Do you agree?
Yes. One
Be-
is over A prime that happened first, and one is A that happened first. So
because both are different, so then it is dependent event.
it's dependent event?
Dependent event. Dependent event. Because both are
Yes, because
different.
each, yeah, so B, given that A has to happen first, makes it a dependent event.
Because the probability
Because
are
A had to
different.
happen first.
Yes.
A
Because
had to happen first, and then B could happen.
not like that. Not like that. I mean like that. I mean like this. If A happen first, the probability of B is bigger. Yeah. If A is not,
Probability that B happens.
yeah.
Yeah.
Look at this. But if A not happen, the probability of B is smaller. Okay.
Okay.
So
Yes.
that so
Yes.
then so
Yes.
then so then the probability of even B is depend on probability of even A.
Yes.
Okay. Do you get the idea of that?
It's dependent. I understand that it's dependent on either
Okay.
A or A prime.
Yes. Okay. Good. Okay. Do you have any question about this?
Okay, so this I understand, but you were trying to explain to me
Okay.
why when they ask what is the problem, whoops, where did it go?
Okay.
When you were saying what is the probability of B, I got that. Hold
Yeah.
on,
Okay.
go back up so I can just follow. Okay, so the probability that B happens once A has happened already
Yes.
is 0.4
Yes.
because of the diagram.
Yes.
But how would I do if I don't have the diagram, which
Oh,
happens
okay.
most times? What would I like? How, which numbers am I plugging in?
Okay. This is conditional probability. Yeah.
Oh, no.
Hold on. It's easy actually. Probability of B given A equals to probability of A and B. And it is usually given, yeah, Rivka.
They don't give any equations on the exam.
How then you calculate the probability if it is not given?
they're not giving any equations. I have to come with every equation, and then they're gonna check my notes.
So this,
Okay, so hold on. The probability of B happening when A is already given, that was like your other diagram, is the probability of A and B happening.
yes,
A and B. So when you do probability of A and B, you do probability of A times probability of B.
yes,
Is that what it is? For the top,
yes.
divided by probability of A.
So
Am I
the
correct?
so the yeah,
When you're doing probability, okay, when the equation on the right, you wrote probability of A and B. If I had to put the numbers there, I would do probability of A
yes.
times probability of B. Correct?
Nah, we cannot say that probability of A and B is equals to probability of A and B. Sorry, probability of A times probability of B. Not like that, yeah. Because like this, Rivka. Okay, for independent event, you are correct. Probability of A and B equals to probability of A times probability of B, yeah. But for dependent
Okay.
event,
That's
probab
an independent event. Okay.
is not
The
equals to
dependent
is not equals to.
event is P and A, P of A, and probability of A and B when it's not dependent. So when it is dependent,
Yes.
it's equal to probability of A. Hold on. Hold on. So this is what they wrote. If A and B are dependent, then P of A and B is equal to P of A times P of B given A.
Ah, I see. Okay, okay, okay. Actually, that's apply for all. That's apply for all, not only for independent or dependent. Yeah. Okay, okay, okay. Okay, okay. And I will give you example. I will
So
give you
how do
example.
I apply that?
Okay, I will give you example. I will give you example. So this formula is apply for all, not only for dependent or independent. It's apply for all condition, Rifka. Okay. Maybe I'll give you example. Maybe I'll give you example. Okay. Given probability of A is 0.6.
Try to stick to the same numbers on top so that I can remember, like try to follow.
Yeah, yeah,
Do you
yeah.
know what I mean?
Maybe like this. I will
Keep
give you
it
example.
together. So then that's 0.6 times 0.5.
Okay.
0.4. Why 0.4?
That is the given condition.
Oh, okay. You just gave me numbers. Okay, I was like, well,
Okay, that's that.
so hold on. So let's just think, I'm gonna think it through, okay? So if you told me, just if I look at the top problem, given probability of A is 0.6 and my probability of B is 0.5.
Yes.
As soon as you get to that second line, it should make sense that probability of A and B should equal a certain number. So if I just take A and B and then you tell me what is the probability of A and B, shouldn't I do 0.6 times 0.5?
No, it is given.
No, but I'm saying, how do you, if if you didn't give me P of A and B, and you asked me the question, what is P, A, and B? Shouldn't my answer be 0.6 times 0.5
Uh,
to get A and B?
okay. That is for independent, and dependent event. Okay.
In the That would be for independent event.
Yeah. So doing this first. Doing this first. I will explain about that later after this.
Okay, can we do it? Because I'm getting confused. I think that's what I need to undo what I'm getting
Okay.
confused about.
Okay.
So first, if you didn't give me A and B yet, no, go back up. If you didn't give me the P, A, and B, you just gave me like probability of A and you gave me probability of B. So you gave me 0.6 and you gave me 0.5. And then the question is, what is the P, A, and B? Right?
Okay.
Then I should be doing P of A, right?
Okay.
Times P of B. So
Yeah.
I should be doing 0.4 times 0.5.
What? No. Okay. Maybe I explain from the
So that's where
beginning.
I'm getting confused.
Okay.
Why
Okay.
am I getting confused then?
Okay. Just follow my instruction. Don't think too far. Okay. I will give you independent event. Independent event.
Why isn't it?
Okay. Independent event. The rule is just like this. Probability of A and B is equals to probability of A.
Times probability of B.
Yes.
Okay.
Just that. So
So
example like this. Example
So
like
why
this.
is it wrong? Then when you just did this example and you gave me point whatever it was, 0.6 and 0.5 or whatever, I don't know what the number was. Why is
Because
it I can't do both times each other? Why am I getting that wrong? Why is that wrong?
because to even doesn't mean that both are independent. It can be dependent. It can be mutually exclusive. Okay. So if you have compound event, two event or more, yeah. So the event can be independent, can be dependent, can be mutually exclusive. So you cannot use this formula for all. You cannot use this formula for all. For dependent event, probability.
It's only if it's dependent. Independent, I'm sorry.
No. You can
Only if
have.
it's independent, you
Yeah,
can use
yeah, yeah,
it,
yeah,
the one
yeah,
on the left.
yeah. Because you can
But
have.
how would I know from your problem that, let's say, event A and then you wrote event B? How am I supposed to know that it's independent or dependent on each other?
It is given. Usually they give you the information that two event is independent or not. Okay.
Mhm.
Yeah. Usually you are given information that two event is independent or not. Okay. Hello.
Okay. So if it's independent, then I get it. So if it's independent, you're saying use this formula.
Yes.
If it is dependent,
You cannot use
then
that.
you use the other formula, which is that famous P A times P B given A.
Okay. You can.
Right?
Yeah. You can use that formula. Actually, that formula is applied for all. That formula apply for
All
all.
meaning independent and dependent?
Yes. Not only for dependent.
Okay, just so what did you write on the right? P of A and B
Not equals to.
is not equals to P of A times P of B.
Yes.
Okay, so if you had P of A and B, that is
Yes.
a dependent event, then how would I find that information?
Okay. I will show
Like
you.
if we did that example, like 0.6, 0.5, then how did you, someone, okay. Mhm.
Okay. Even A and even B. are
So
independent.
that would be 0.6 times 0.5 because it's
Yes.
independent. So that would be correct.
Yes, correct.
Okay, and then for the dependent event,
Okay. Oh, sorry, 0.3. Yeah. Okay, given probability of A 0.6, probability of B 0.5, even A and even B are dependent. So calculate probability of even A and B.
okay. So then you have probability of A and probability of B given A.
So the answer is cannot be determined.
What?
Yeah, not enough information.
Okay, so stop right there because this is the part I'm very confused about. This
Yeah, yeah.
dependent.
If even okay, if you know even PA and you know PB and you know that two events
So we
are
have those
dependent,
information.
so we cannot find out probability of A and B. We cannot. We cannot. Yeah, you cannot find out probability of A
Let's
and B.
break it. Okay, I hear what you're saying, but could we break it up so I can see that it can't happen? Like I'm thinking, if I were to do the equation that they said, which is probability of A
Yes.
times probability of B given A, right? To get the probability of A and B when
Yes.
it's dependent. Then if I break that up, probability of A is 0.6 times the probability of B given A. The reason you can't do it,
Yeah. Okay,
why
continue.
can't you do it?
No,
Is
okay,
because,
okay.
hold on. So probability of B given A, isn't it given A?
Okay,
So
okay,
wouldn't it
okay.
be 0.5 times 0.6?
Rivka, I give you probability of B, not give you probability of B given A. Look at this, the symbol. Okay.
I can't see what you're writing.
Look at this. I give you probability of A 0.6 and probability of B 0.5. Okay.
Okay.
So it is not probability of B given A. It's just probability of B.
Okay. And if you, how would, how would, how would they present probability of B given A?
This.
How can you?
So this
Where are
is
you?
okay. Okay. I will give you example with that question. But after this, because this is the basics of compound event. You can have
Mhm.
independent event, dependent event, and mutually exclusive event or disjoint event. Okay, this is mutually exclusive.
That's for only addition, correct?
Yes. So probability of A and B is 0, yeah. Okay. Because even A and even B cannot happen at the same time, cannot happen together. Okay.
Mutually exclusive, wouldn't it be P of A or B?
No, 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 no. Yeah.
Yes,
Okay.
it
Okay.
is.
Okay. This is the basic first. This is the basic. Mutually exclusive event or disjoint event, the probability of A and B equals to 0 because even A and even B cannot happen at the same time. Okay.
Yeah.
For example, probability of A is 0.6, probability of B is 0.5, even A and even B are mutually exclusive. Ya. Calculate probability of A and B. So the answer is 0.
So you already confused me. I'm going to tell you why.
Why?
Because you're saying probability of A and B is equal to 0.
Yes, that is
Isn't
0.
it as soon as they use the word and, it's going to be a multiplication?
Okay, I need to repeat again. N doesn't mean multiplication. Sorry. N means multiplication if only the event are independent. N doesn't mean multiplication.
And is not multiplication? Is
Not
so it's only multiplication
for
when
independent event.
it's an independent event. Okay, hold on. So I would never have written this. I don't know. I would have read P N A N B, and I'm gonna say 0.6 times point B, 0.5. That's what I would say.
For what? For? Hello,
If
hello.
you wrote P A N B, can you hear me?
Yes, yes.
As soon as you write P A N B, I'm thinking 0.6 times 0.5.
No, that is wrong. You need to
Oh,
you need to know, is it independent event, is it dependent event, or is it mutually exclusive event? If it is independent event, you can multiply like that. But if not, you cannot do like that. For example, like this. Oh, sorry. Maybe I change this. This is 0.3, not 0.5 because impossible. So if two event cannot happen together, how you can find out probability of A and B? Even A and even B mutually exclusive. Okay, I will show you using Venn diagram.
no, so I am understanding that when you see mutually exclusive, it's PA or B that is equal to 0.
Not P A or B. P. Okay. I will show you. This rule, the union rule is okay. I will show you. You need to memorize union rule. Union rule is apply for all condition, not only the independent event. It's apply for all. It's apply for independent event, dependent event, and mutually exclusive event. So union rule is like this: probability of A or B equals to probability of A plus probability of B minus probability of A and B. Yeah. And
Yes, that would be
and
for the addition, but
okay.
that's only if it's not mutually exclusive.
Okay, the condition is like this. Independent event means probability of A and B equals to probability of A times probability of B. For dependent event, probability of A and B is not equals to. So and then
For a dependent event, then you would have, for dependent event, probably of A and B would be this famous P of A times P of B given A. No?
yeah, that is correct. But yeah, that's correct. You can use that. But we were okay.
So
But
how do I use that?
yeah, okay. You use that when you given the information. Let's say
Okay, so just write it. Okay.
okay. So
Just go back up a second. Hold on. So I can go back and then find it.
okay.
Under dependent event, right? You
Yes.
put P of A and B is like not able to be P of A times P of
Yes.
B.
Yes.
Can you
Correct.
write it P of A and B is P of A times P of B given A, correct?
Yes. Correct.
Okay, can you just write it down so when I copy it, I remember that?
Okay, actually that's apply for all. That's apply for all for independent event and also for dependent event.
Okay.
So probability of B is equals, oh sorry, probability of A and B, yeah. Okay, probability of A times probability of given A. Okay, like this.
All right, so just explain this. The probability of A and B is the probability of A. That's these would be
Okay, maybe
independent, no, dependent events. You said dependent.
okay.
So this,
It is apply for independent and dependent. Yeah, it's apply for all for independent and dependent.
okay. So now if we were to plug in those numbers that we had, the A and the B, how would we do this here?
Okay. Let's say like this. Let's say you are given this condition here. Okay, wait. Maybe like this. Yeah. Okay, probability of A is 0.4, probability of B given A is 0.7. Okay, so calculate probability of A and B.
Now, if they're asking me, so if they're giving me probability of A and they're giving me probability of B given A. So, and they want to know what is the probability of giving B, the probability of A and B. So if I go back to this famous equation that they had, is that what it
Yes.
was? So I would go to probability of A, which is 0.4 uh, times 0.7.
Okay, you are correct.
Okay. Now, okay, so let's pause here. Now, what
Yes.
happened if that would be for probability of A and B, right?
Yes.
But if you gave me probability of A is 0.4,
Okay.
and then you gave me probability of B being, I don't know what it's gonna be.
Okay, let's say 0.
Probability of B is gonna be, let's say 0.2, I don't know.
Okay,
No
okay.
idea.
Okay, so what is the question then?
0.6, okay. 0.6. Then if they told me, how do you calculate probability of B given A? How do I do that?
How we know probability of B given A? Okay, probability of B given A. So this, yeah. So you need
Yeah.
you need more information. You need this.
Okay. So if they gave you, you're saying if they gave you probability of A and B,
Okay, okay. Okay.
A and
Sorry,
B.
sorry,
So
sorry.
my equation,
Okay, hold on. I'll explain for all. We know probability of A is 0.4. We know probability
that's
of B
correct.
is 0.6. Okay. The
Okay.
you need more information. Okay. Is even A and B, even A and even B independent. Okay, the question is even A and even B independent or not, Rivka? So because you don't
Well,
tell
if
me,
they're the
because you
so
don't
hold
tell
on,
me.
let's just think. So I hear you. So how would I know if I needed to say that it was independent? Then event I can't calculate event A or B
Okay,
if it's dependent.
if in
Independent, I'm sorry.
if independent,
Then
so
there's no such a thing as B given A. Or is it?
yeah, if independent, so
It's
probability of B given A, it will be 0.6.
why? No. No, I don't understand that. Okay, explain that.
Okay, I will show you. I will show you. Because if independent, probability of B given A will be same as probability of B given A prime. Yeah. And because this is and then this is same as probability of B.
Okay,
Yeah.
pause. I just have to figure this out. So you say the probability of
Yeah. So okay. If even A and B independent, so probability of B given A is same as with probability of B, and same as with probability of B given A prime. So just memorize that. Okay, I will explain using tree diagram. Hello.
yeah.
Okay, I'll explain using tree diagram. So this is
I don't
a
understand how they're saying if something's independent, how could it be something B given A? That's already making it dependent on A.
okay. B given A. It doesn't mean that if
I thought you
I
have B given A.
yeah B given A, it doesn't mean that it is the in the okay if you okay B given A, it means probability of even B happen given even A happen first. Okay, do you know what is the difference between independent and dependent?
Before B can happen.
So either independent or dependent, both even A and even B can happen together actually. Okay,
In independent,
for both independent and dependent means both event can happen together.
it can happen.
Okay,
They can happen together. They're not linked. Each
they,
one happens on its own. Yes,
what do you mean it
no, am I
happen with the with what do you mean with happen it's their own?
like before when you had A and B, right?
Okay,
So event A happened, that's one independent event. Event B happened, that's an independent event. But then as soon as you made them dependent of each other, that's when they link.
okay, they link. Yeah, but both can happen together actually.
So that's what I'm saying. I don't think an independent event can happen B given A. I don't think that is possible. You can only, if event A has to happen first, then it can't be independent. B can't be independent. It's got to be dependent on A.
Okay, when even A happen first and is not affect even B, so it will be independent.
Yes, but then there's no such a question that could be B given A then.
Okay. So actually like this, yeah. For independent event, you can have this question. you can also have this question for independent event. So this question not only for dependent event, you can have this
So
question
I
for.
don't understand why you can have it for independent. I don't understand that.
Sorry.
How can you have that? I don't understand how you can have T be a given A in an independent. I can understand it in a dependent, but I don't understand it in an independent. In an independent, how could they even be one given the other? It's not. They're separate. There's two different entities.
Okay. Even B
How
can have
can you answer this question?
even B can happen when the event A happen first. But the probability of event B happen
That would
is
make it dependent.
not like that. Not like that. I will show you. I will show you. This is the tree diagram of independent event. Let's say this is 0.7, this is 0.3, and this is B, this is B prime. So let's say this is 0.4, 0.6.
Okay, so this already you lost me. You know why? Because to me, this is not an independent event. This to me looks like a dependent event.
Why?
Because unless A happens, B or B prime can't happen.
Okay, this is
So to me,
independent.
this
Okay,
is
okay,
dependent.
okay. Look at this tree diagram. Is this independent or dependent?
This is dependent.
No, this is independent because the probability of
Yeah,
B.
I would think independent would be A on the top and B on the bottom.
Not like that. Not like that. This is independent.
I don't understand how it's
So
independent.
okay,
No.
okay. I
Why
think
is it A independent?
okay. Just use my my explanation. Okay, this is independent event because this is not changing. Probability of even B, yeah. Probability of B given A is 0.4 and probability of B given A prime is 0.4 because probability of B given A is equals to probability of B given A prime, then this is independent event. And because it is already same, so we can find out probability of B is 0.4. Okay, so the tree diagram to represent independent event or dependent event is like this, not like this. Okay,
Yes, that's what I would think is independent.
so if you have this, it is not compound event. Compound event you will have branch like this because you have two event. Two event means like this, yeah. Okay, so just use this tree diagram to understand.
But even if I did the tree diagram, I'm just telling you, I would never have put A prime on the bottom. I would have put A and B,
Why?
and then because it's two separate events.
Two separate event. And then how you can represent A prime? Okay. Let's say I give you this. Probability of A is 0.3.
Mm-hmm.
Okay.
Mm-hmm.
Even A. The question is grab the tree diagram. Okay. I want you to show how to grab the tree diagram if you have this information.
Event A and event B are independent. The probability of A, I would just write A
Okay.
happening. So event like event A would be 0.3 probability,
Okay.
and event B would be 0.4 probability, two separate lines.
Okay.
So
Like that,
event
like that.
A
Can
and
can
B,
you
two separate, and
can you show it to me?
here, I'm gonna try. Yeah. So if P of A is equal to 0.3 and P of B is equal to 0.4, you want to know event A and B are independent. We have the tree diagram. So I would have done event A, event B, and then you want to know A and B. So it's independent event. So it'd be P of A times P of B. What's the equation? Times P of B. So I would do 0.4 times 0.3.
No, okay. How you grab the tree diagram? How
I just did this. This
Okay,
is
sorry. Can you make it closer?
0.3 and yeah, I'm gonna do it. Hold on, 0.4.
Okay. What is A prime?
I don't have A prime.
Of course, you will have A prime. Impossible that you don't have A prime because because probability of A plus probability of A prime will be 1. So how I can see A prime from that tree
Probability of
diagram?
A plus the probability of A prime is equal to 1. So you're saying probability of A, which is 0.3, plus the probability of A prime is equal to 1. So it'd be 1 minus 0.3, which is
Okay.
0.7.
So where is that?
So A prime would be, A prime is equal to 0.7.
So how you will grab that? How you will grab A prime on that tree diagram?
I don't know. I mean, what makes sense from the numbers is almost like A prime is at the beginning,
Okay.
like here.
Okay. So A prime at the beginning. Okay, okay. Yeah. That is wrong. That is wrong. I'm sorry, but I need to say that that is wrong.
That's fine. Don't worry. I'm happy you can undo this.
So yeah, I think we need to review from the basic again. Yeah. Okay, okay. It's okay. I will extend the time for free. Okay, okay. Do you see my share screen?
Yeah.
Okay. I will explain from the basic. Yeah, I'll explain from basic. We know even probability of A is 0.3, probability of B is 0.4. Okay, even A and even B are
Mhm.
independent. How we graph the tree diagram? So it will be like this. This is A, this is A prime. So A is 0.3, A prime is 0.7. Yeah, because we know
Okay.
probability of A plus probability of A prime will be 1. Agree?
So probability of A plus probability of A prime is equal to 1. That's
Yes.
correct.
Okay, we know even A and even B are independent. So it means this will be same with this. And this will same with this. Just that.
Okay, stop. You just said event B is 0.4. So I understand that. And so even for A prime, it would be 0.4.
Sorry, A prime.
Even for like the B of A prime, it would be
Yes. Oh,
0.4.
yeah. Yes, correct.
Why? Why?
Because independent. So the probability of even B happen is not depend on what happened first. It's not depend on what happened first. If A happened first, the probability of even B is 0.4. If A prime happened first, probability of even B also same 0.4. Okay.
So regardless, basically what you're saying is that B will be 0.4 if A happens or if A doesn't happen.
Yes.
Because A prime means it doesn't happen.
Yes. Correct.
Okay. We're getting somewhere. Okay.
So this.
Probability of B given A prime.
So then we probability of B, it will be 0.4. Yeah. Okay. Just that.
Yeah,
Oh,
but they didn't give you probability of B given A. So if they just gave you the numbers, how would you have calculated B given A?
okay. Actually, we use this formula, Rivka. If they're asking you probability of B given A, so we just use this formula. Where's the formula? I forget. Oh, this. So if they ask you probability of B given A, of course they will give you probability of A and B and probability of A. So you can calculate probability of B given A using this formula.
Okay, so that's okay. So now you're talking. So probability of A given B would be probability of A and B given B. Okay, no, probably. Okay, fine. 1 second. So probability of B given A would be probability of A and B. You're back to square one. I want you to do the probability of A and B. And how do you, if you put this equation in, what numbers am I putting in?
Okay.
0.4 times point B, 20 times point, what was it? Hold on. What was A? I lost it. What was A? 0.3. So 0.3 and this was 0.7. So it would be, for the top of the equation, it would be 0.3 times 0.4
Yes.
divided by 0.4.
For what? B given A or A given
B
B?
given A.
So
No,
probability.
B given A. So if I had probability of B given A, right, and I
Yes.
plug it into the formula, it would give me the probability of A, which is 0.3 times
Yes.
0.4 divided by 0.3.
Yes. Correct.
Does that make sense? Does
Yes.
that make sense?
Yeah. But okay.
And then
Hold on. Okay. You are given the tree diagram or not? Hello.
no,
If
no.
okay. If, let's say like this. Let's say like this. You are not given the tree diagram. Yeah. So
Okay.
so I give you probability of A and B. Let's
Mm-hmm.
say 0.4. Yeah. Probability of A
Mm-hmm.
is 0.5. Probability of B is 0.6. The question is
Okay.
probability of B given A, and the second question is probability of A given B.
Okay.
How you answer this?
So then I would take these equations. So probability of B given A would be hold on, do you have the same numbers? Probability of A, you gave me A and B. So probability of A and B, I would do so 0.4 divided by 0.5.
Yes, correct.
And then the other one would be what is this? Probability of A and B. So same thing. You would do 0.4 divided by 0.6.
Yes, correct. Just that. Done.
Okay. All right.
Okay,
Okay.
okay,
Okay. We're getting somewhere.
okay,
You're working. You're working with me.
okay. This is when you are given the information. Yeah, this is when you given the information.
Mm-hmm.
But what
Yes.
if you given? What if you given the Venn diagram like this? Okay, it's a little bit messy. Sorry. let's say this is 0.3, 0.5, 0.1.
Mhm.
Okay, the question is what is probability of A? What is probability of B? What is probability of A and B? What is probability of B given A? Okay, done.
The probability of A, probability of B, probability of A and B,
Yes.
probability of B given A, and probability of A given B. Okay. So let's do probability of A. Anything that's probability of A is 0.5 plus point, so 0.8.
Okay, I agree. Good.
Okay, and then probability of B is 0.4.
Okay, I
And
agree.
then probability of A and B. Hold on. Probability of A and B. That's B. Uh, so it's that equation, probability of A and B. A and B. So it's probability of A times probability of B. You see, that's where I'm stuck. I don't know. Is it two
No, no,
separate
no,
events?
no, no, cannot. You cannot multiply. You just see from the intersection. A and B is the intersection.
So there's what? So we go back. So what's my equation for P, A, and B? Isn't it P, A, and B? We go to P of A
No,
times
no,
P,
no, cannot.
B
Because
given.
Rivka, because you don't given the information that even A and even B are independent. If even A and even B
They're not telling me.
independent, you can multiply like that. But if not, you cannot do like that.
So how would I know they're independent or dependent? It just didn't tell me. There's no
So
way for me to know that there's. If
okay,
it wasn't
okay,
it that if it's independent, it would be two separate circles?
no. Two separate circle means mutually exclusive. Okay, okay. We continue. We continue. A and B we find from Venn diagram. A and B we find from the intersection. Okay.
Okay.
So what is the intersection?
It's the two then that are merged, like that are together.
So what is the value on the intersection?
0.3.
Okay, good. So
Okay.
okay, clear, yeah, clear. It is clear. So probability of A and B is 0.3. Now you can continue.
Mm-hmm.
Probability of B given A.
Okay. So the probability of B given A. The probability of B given A is probably, so it would be 0.3 divided by 0.5.
Why 0.5?
No, divided by sorry, no, divided by 0.8.
Okay, I agree. Good.
Okay, probability of A and B, A given B, it would be probability of A and B, which is 0.3 divided by 0.4. Okay, I'm still confused about the A and B. Why it's 0.3? Because in the Venn diagram, yeah, I can see it's 0.3. But if I
Okay.
don't have the Venn diagram, that's where I'm getting stuck.
Okay, if you're not given the Venn diagram, yeah, let's say you are given like this, yeah. So calculate, maybe not 0.5. I think I changing this, yeah. Calculate probability of A and B when when even A. Okay, sorry. Maybe. Okay, probability of A is 0.4, probability of B is 0.5. Okay, calculate probability of A and B. Why my handwriting is like this? I don't know why.
Don't worry, you're writing just fine.
Calculate probability of A and B. A, if both are independent. If both event are independent.
If they're independent. If it's independent, so if independent, then it's A times B.
Yes.
Probability of
Yes.
A times probability of B.
Yes.
Okay, but if it's not dependent,
So you cannot find out probability of A and B using this information only. You cannot.
so they have to give me, to be able to do the B given A, if I wanted to apply that formula,
Yes.
then they have to give me A and they have to give me what?
Yeah.
What do
Okay.
they need to give me?
Okay. Let's say you are given
They would
this.
have to give me B given A.
Yes, B given A.
It's incomplete
Yes, incomplete.
if they don't give me.
Yeah, but actually this formula, probability of A, sorry, probability of B given A is equals to probability of A and B over probability of A is applied for both independent event or dependent event. But specially, you will use this for dependent event to find out probability of A and B. Okay?
Okay. So I'll use it the other way. You cross multiply and
Yes.
divide. That's what you're saying.
Yes.
That
So
point.
so this will be 0.4 times 0.5 here. How about this, Rivka, for B? Both events are mutually
Both
exclusive.
events are mutually exclusive. Mutually exclusive means they're two separate events. Do you want me to calculate A and B? Mutually exclusive. Hold on. If they are, so if my P of A is 0.4 and my P of B is 0.5, and you want to calculate P, A, and B, and they're mutually exclusive. Mutually
Yes.
exclusive means it's P of A times P, no, not times, plus P of B. No? Yeah, if
No.
they're mutually exclusive, P of A plus P of B.
No. Because that is for OR. Hello? Sorry.
Yeah, I'm lost.
Okay,
No.
Rivka, I asking probability of A and B. So for mutually exclusive, because there is no intersection, because even B and even B cannot happen together, so probability of A and B will be 0. Yeah, 0, 0.
If they're mutually exclusive, it's going to be 0
Yes,
because you're saying because A can't happen,
yes.
it can't enter, A can't is not intersecting
Yeah,
with B.
so this is the graph of mutually exclusive event. Ta-da.
Yeah, the two separate zeros. Yeah. I think I'm getting mixed up between mutually exclusive and independent.
Okay, okay.
You understand what I'm saying? Because when I see these two, I think they're independent of each other.
No, it's not like that, the meaning of independent. Independent and dependent, they have intersection. They both have intersection. Okay? Do you get the idea of
They
that?
both have interest.
Yeah. So this is dependent event. Okay, I will show you. I will show you the two. Okay, I will show you independent event and dependent event using Venn diagram. Yeah.
Mm-hmm.
Okay, I think this enough.
Okay.
Okay, so this is independent.
Both of them are independent?
This is dependent. Okay, I will explain why. Okay, what is probability of A here?
0.5,
Okay, probability of B.
0.4.
Okay, probability of A and B.
Hold on. And you said they're independent.
No,
So
no,
there is
just see.
probably an
Sorry,
A,
sorry. Just see from the Venn diagram.
0.2.
Okay, we know for independent event, the rule is like this. Okay, so because probability of A and B is same as probability of A times probability of B, then this is
Got
independent
you.
event. Okay,
Mm-hmm.
because 0.2 is same as 0.5 times 0.4. So that
Okay, got
this,
you.
okay. Next on the right side, what is probability of A
0.5.
and probability of B?
0.3.
Okay, what is probability of A and B?
0.2.
Okay, so we check, yeah, using the rule. We check for the rule of independent event. Okay,
Okay, so that would equal up.
it is not equal, say, it is not fulfill the rule for independent event. So this will be dependent. Yeah, because probability of A and B is not equals to probability of A times probability of B.
Okay,
Just
so you could plug it in to verify that it should add up, and
what
then you'll know if it's independent or dependent.
what do you mean with add up?
Like what you just did now, you showed me that it's a dependent event because it doesn't add up with this equation.
Yes, yes, correct. Does not fulfill the equation. Okay.
Mm-hmm.
Okay, now,
Okay, so what does
okay.
that have to do with mutually exclusive?
So the graph of mutual exclusive, there is no intersection, Rivka.
Yeah, but when you have just numbers, if you have a Venn diagram, then fine. But if it's not a Venn diagram, how do you know it's mutually exclusive event or not?
It is given the condition. Okay, okay. Maybe like this. Maybe like this. What question that you want to ask? Maybe what type of question? Like finding probability of A and B or what?
So one second, let me ask you a question. Is something that's mutually exclusive, you can't ask the question of A and B, or you could?
You can. Okay, maybe this, yeah. Maybe this question. Hold on. I will make question for you. Even A and event B are mutually exclusive.
Okay.
Okay. Maybe this. Yes, that. Okay.
Event A is 0.6
And
and event B, what was the other number? 0.6, what was A? That was A and B was 0.3.
yes.
Okay, you want P, A, and B. You want the P, A, and B. So I would have done the 0.6 times 0.3 automatically.
No, you cannot do that because mutually exclusive. Okay, mutual exclusive, it's just 0. Okay, hello. Mutual
I'm
ex
lost.
okay, mutual ex okay. Better for you to grab the information into Venn diagram, Rivka. This will be helpful. Mutual exclusive means the circle not intersect.
Okay, that I understand.
So you can see no intersection, okay? Because no intersection, so probability of A and B will be 0. Yeah, okay.
Okay.
Do you agree with that? Do you agree
Okay,
with
hold
that?
on. But if you go, I understand when you're saying that, but yeah, I don't. When they gave me 0.6, I put it in A, and then a 0.3, put it in B.
Yes.
What shows me here? Like, if I'm drawing the Venn diagram, why am I not intersecting it? Why am I assuming just because it's mutually exclusive, that's how I know it's two separate circles?
Yeah, because you are given the information that two events are mutually
Yeah, that's what I'm saying,
exclusive.
because it says mutually exclusive. So if it's mutually exclusive, then it's two separate
Yes.
like circles.
Yes.
Okay. So okay, and then PA or B would be 0.6 plus point B,
Yes.
0.6 plus 0.3. Yeah.
Yes. So just that.
Okay.
Correct.
And so then how would they name it if they wanted it to intersect? Not mute like this joint is mutually exclusive.
Yeah, mutual exclusive
So
is
how would you say it means this joint? But how would you like if you had to intersect them,
yeah,
then you would say what? That they are
independent or dependent. So independent or dependent will have intersection like this. But
independent or dependent will always have intersections.
yes.
Oh,
And independent will
I didn't
fulfill
get
this
that.
and independent will fulfill this equation. Dependent not fulfills this equation. Okay.
Let me see. Intersecting. Okay, you just really enlightened me because I think that's where I was getting so confused. Okay, I need to write this all down. Okay, how are you going to be able to send this to me?
Okay, I will send it to you after I upload this. But it's almost 1 hour,
Okay,
but it's okay.
yeah. No, I know it's almost 1 hour. Okay,
No, no,
all right. Okay, so that's that.
no, I mean the video is quite long, so it takes so long to upload.
Oh, you think it's going to take you time? Okay, because I have to put it together and try to get all these equations in one piece. in like one thing so I can get it. Okay. Are you able to do it like soon? I don't want to put pressure on you. I know you have other things to do.
Yeah, it's okay. I will upload after this.
Okay. All right. So then I need to meet with you if you can, like later on to do the other, like that binomial probability distribution.
Yeah, yeah, okay. What time?
Hold on. Give me 1 second. Sorry, I'm just checking my blah, blah, blah. 1 second. Would 3 o'clock work? Is that too early for you?
Maybe like previous or like 6, yeah, it's okay.
What did you say? I didn't catch. Just
Oh
say it
yeah,
again.
like what we did before, like 6.
Is 5:30 good or six
Yeah,
better?
yeah, 6. I think I prefer 6.
Yeah? Okay. So
Yes.
let's do 6:15. Oh my gosh. Oh my God. Okay. So as soon as you can upload this, I'm gonna go through it so I can write down all these equations.
Yes, yes.
And where should I look for it?
I will send
Where
the
should
link.
I find it? Like how
Yeah, I will send the link on
you'll send
yeah,
on where? That's what I'm asking where.
on YouTube. So you can watch
No,
YouTube.
but you're gonna send the link to my
On
no, but how will I know the link?
on SuperProf. Okay, I will send it.
Okay, perfect. Thank you so much. I really appreciate this. Oh my God, that was like so important. Thank you.
Yeah, it's okay.
All right.
I think the problem for tonight lesson is the misunderstanding from the beginning. I think from the basic.
The probability is very confusing.
Yeah,
Very
yeah.
confusing. Okay. Hopefully you'll have something to tell. Just like, okay. I'll see you. Thank you. I'll see you later tonight.
Okay, okay.
Bye.
No, no, no. I think like this. Yeah, because probability is quite hard to understand. Quite hard to understand because you need imagination, and sometimes what you think before is different with the actual thing. Yeah. So you have uh you already have the concept, but the concept uh uh is wrong. Because that it's like we need to rebuild your understanding. So because that is it's like it's not like before, yeah. When you don't understand something, it's easier to learn rather than you understand, but it is like misconception. I think for tonight lesson. Hello.